Hello students, welcome back to your science class. So students, today we will going to start with a new chapter, and that is magnetic effect of electric current. You see student, in the previous chapter we had discussed about the importance of electricity, what is the role of electricity in our house, in our life. Our life is basically incomplete without it, whether we work in an office, whether we work in a home. Every time we are dependent upon the availability of electricity. A lot of appliances that we use, that is also work because of the electricity only. And in this chapter we will going to understand that one of the effect of the electricity. You see, uh, I think that in the previous classes you have already knew or already know the concept that what is the effect of electricity, and here uh, uh, till date we are knowing that what is the chemical effect of electric current and what is the heating effect of electric current. So chemical effect of electric current is responsible for the process of electrolysis, where the when the elements comes in, when the metals comes into the molten state, and they get breakdown into the smaller pieces or into the ions, and the ions are responsible for the movement of the electric current, that help in the electricity to flow through it. So the electrolysis is the one of the effect of the current, and that we will include. Since this effect is caused due to the chemicals, because of that it is called as a chemical effect of electric current. So electricity is responsible for the breakdown of the elements into the ions. That is why it is called as electrolysis or electrolytic conduction. Second one is the heating effect of electric current. So heating effect of electric current, we have understood that when electricity passes through an appliances or through any object, it will produces heat. Like iron, electric iron is there, or immersion rod is there, anything, right? So basically there are different effect of electricity, and out of the two, in this chapter we will understand that electricity and electric current, as well as the magnetic, these both of them are what they are synonymous to each other. It means both of them are dependent to each other. So with the help of the electric current we are able to produce magnetic field, and with the continuous change in the magnetic field we are able to produce the electric current. Okay, so that is why we will going to the name of the chapter is the magnetic effect of electric current. Okay, it means because of the electricity, because of the electric current passes, it will produces a magnetic field around it. So lot of appliances students, like an electric bell is there, this work on this principle, that is the magnetic effect. Okay, so basically when I am saying that the electric current, it passes through that of the magnetic, when electricity passes through a conductor, a current carrying conductor produces a magnetic field. So let us try to understand with the help of this activity. So here for this activity you can see in the diagram itself, it explains that here this X and Y is what? It is a thick copper wire which is placed, a plane of a paper is there student, and it is connected with a cell, resistor is there, emitter, and we will insert a key also. And it means the battery is here in order to provide the electric current. So we can say that so as you can see here students, that this is a copper wire, this one is a copper wire, and this will, so when the current is supplied to it students from that of the battery, what happened to this copper wire which is an XY here, if you place a magnetic compass is there in order to find that if magnetic field is produced or not. You know that the magnetic compass is actually a kind of a bar magnet which used to align itself in the north and south direction. So by keeping the magnetic compass near to that of the copper wire, you will find that there is a deflection to that of the needle, okay, to that of the compass. Okay, so why there is a change in the position of the compass needle, students? So this proves that there is a magnetic field produced around this copper wire, due to which the deflection can be seen, and hence by this we can prove that when the current flows through a wire, through a copper wire or through a wire, what happened to a current carrying conductor, then yes, there is a formation of a magnetic field, production of the magnetic field, and this we can see by the needle, the deflection of the needle. Even the reverse possibility is also possible, student. It means when there is a continuous change in the magnetic field, then electric current can be produced, and it is because of that it is written that the reverse possibility of an electric effect can move the magnet, right? So we can say that the electricity and magnetism are linked to each other. They are synonymous to each other. Okay. Now see, this this magnetism, it was first of all given by Hans Christian Ørsted, and here he was working with the compass needle, and uh, you will find he just accidentally he found out that he kept that compass needle near to the current carrying conductor, and he found that there is a deflection shown by the magnetic compass, and this is how the concept of the electromagnetism came. And you know that today all the appliances that we use, basically it works on the electromagnetic induction. It depends on the magnetic field strength. So radio, television is there, fiber optics is there. These all are basically, they work on the high tension wire is there, transformer is there, everything, washing machine, motor, all these things work on the principle of the electromagnetism. So it was the Hans Christian Ørsted who worked on it, and because of this he was honored by giving name as a Ørsted by to the unit of the magnetic field strength. Okay, so magnetic field strength is named as the Ørsted in his honor. Now come to the magnetic field and field line. Magnetic field. Okay, so basically we know that we are very familiar with the compass, and when we keep a small magnetic needle near a bar magnet, the magnetic needle starts rotating, and it will stops at a particular direction only. What does that it indicate? It indicate that the force act on the magnetic needle, and this make it rotate and rest in a particular direction, right? And because of that, there is a because of that the concept of the magnetic field can be explained that yes, because the current flows or the compass needle is moving in the north or south, or is just deflecting, it means that there is a magnetic field. So we can say that what is a magnetic field? Magnetic field is nothing but it is the region around the magnet where the force on the magnetic needle occur, and the needle, it stops at the specific direction, that we call as a magnetic field. It means it is the region, it is the area where the magnetic force can be felt, can be the effect is there in that particular area, that is called as the magnetic field here. So we can see here, we can understand that the magnetic compass, see, when we talk about the bar magnet or any of the magnet, every magnet, they used to, the end point is always north and south. So as you can see here, student, it is written that as you can see, it is written here that a compass needle is in fact a small bar magnet, and the end of the compass needle, it points approximately towards the north and south direction, and the end pointing towards the north is called north pole, while the other end that point towards the south is called as the south pole. Basically, when we kept the magnetic compass in a area where the magnetic effect can be felt, there you will find the magnetic compass start showing, it starts showing the deflection. So the magnetic compass needle is what it actually deflect always in two direction only, that is north and south direction. So the end point towards the north is that of the north pole, and the other end point, that is the south pole. Okay, so basically the compass is there which help in giving the direction, that is north pole and south pole. It is because of that it used to deflect only towards the north and south direction. Here one thing that must be clear, that when we talk about the magnet, student, you know that the bar magnet or any magnet consisting of two poles, north pole and south pole, and these two poles are what? They are having a property in which the like poles they repel each other and the unlike poles they attract each other. It means suppose we will take two magnets, two bar magnet, and these two bar magnet, if they are kept close to each other, remember that if they are repelling each other, then they both of them are at the same pole. It means suppose we have taken one bar magnet A and other bar magnet B. Okay, and if this bar magnet is having north pole and we will take another bar magnet, this is also having the north pole, so they will start repelling each other. Okay, but if out of the two, one is north and other one is south, then what happened? They starts attracting each other. So we can say here that the north pole or the like poles they repel each other, while the unlike poles they attract each other. Now you see, students, the magnetic field, in the magnetic field you will find that the magnetic field, the direction of the magnetic field, it is represented by magnetic line of forces. Okay, direction of the magnetic field is represented by the magnetic line of forces, and they always it can be the magnetic line of forces can be drawn with the help of the magnetic needle. Direction of the magnetic needle, it help in giving the path, and that path is the magnetic line of forces, and it always move from north to south. So these magnetic line of forces, they are having some properties, and that is the magnetic line of force always start from the north pole and end at the south pole of the magnet. What does that mean? It means if suppose we will take a bar magnet, let us see this activity. In this activity you will find that if we will take a white paper on a drawing board, and we will keep a bar magnet in the center of it and just simply sprinkle the iron fillings around that of the bar magnet. Okay. Now when you sprinkle it, and then like you just sprinkle this salt, okay, while using while in that of the vegetable or anything, so there you sprinkle the salt there. Here also we will take the iron fillings and sprinkle near to that of the bar magnet, and simply if we gently tap that of the board, what we will find? We will find that these iron fillings, they start arranging themselves in the pattern, in a pattern, and you can see here what kind of a pattern you will find, that you can see that the lines are it is find a curve path. When you look at here, it's a kind of a curve path which started from that of the north and ended to that of the south. So it's a kind of a curved path. This curved path that you are looking at is the line of forces, and this line of forces, it starts from the north pole and end at the south pole. Okay, so you can see here it is written that the magnet, the iron filling, it experiences a force, and this force, it makes the the iron filings to arrange in a pattern, and that pattern is a curved line. So we can say that the magnetic line of forces which is formed here, or the magnetic field which is produced here, this field line, it is in a curved path. Okay, so that's why it is said that it is arranged in a pattern. Now we can understand it with the help of a magnetic compass also, students. In case of this, again we will take a white paper, we will fix a magnet on the white sheet, and we will also bound a boundary of the magnet. Now what we will do, we will going to take place a magnetic compass near to that of the north pole of the magnet. So see here, if it is the north pole, we will going to keep that of the magnetic compass near to the north pole, and let us see that what kind of a direction it will show. So as you can see here, when the magnetic compass is kept at the north pole, what kind of direction it will going to show, students? So here you will find that, yeah, here you can see when you kept the magnetic compass, then the south pole of the compass needle and the north pole of the compass will be away from the magnet, while the south pole of the compass is near, or is to the north pole of the magnet. See here, this is the north pole, student, this is that of the compass. So this arrow is showing that it is the north pole, and this is the south pole. So this south pole is near to the north pole of the magnet, and the north pole of the needle is away from that of the magnet. Now what we will do, again we will make a mark here, we will make a point here in order to understand what was the first position. Okay, and then at the same position we will keep, if suppose we will mark here, again we will going to keep a magnet at this particular mark. When you did that, again we will see that what kind of a direction is showing at that position. So there also, by keeping the magnet at the previous at the previous north pole, north pole of the needle, you will find that again it will show a direction in which it will be away from the north pole of the needle will be away from the previous north pole, and its south pole will be close to the previous north pole. So it will be like this. You can see this arrow is showing that the south pole is close to that of the magnet, and this north pole is away from that of the magnet. Okay, we will make a point or a mark there. When we keep the magnetic compass, again we will found that this time the north pole will be it is away from the previous north pole. It means it will be away from the mark which we have done there, and the south pole will be closer to it, or the south pole will be in the direction of the previous north pole. So it's the same thing we will going to do again and again, students. So what we will find out, if we will proceed step by step, and finally while doing so, what kind of a structure that you will find here, every time here what you will find that first every time, if you keep, every time there is a position, see this is, these dots are explaining the mark which is made by that of the magnetic compass, and when we keep the magnetic compass to the mark, we will find out the north pole. Okay, so what kind of a mark, what kind of a dot we will find, if we will join all these dots, what kind of a structure that we will find? We find out that it's a kind of a curved structure in which it is emerging from that of the north pole and entering into that of the south pole. So a line is starting, the magnetic field lines are starting, it emerges out, it comes out from that of the north pole and it enters into the south pole. Okay, so if we will going to repeat this procedure and see, then we can draw many lines, and all the lines will going to show a kind of a pattern that you can see in the figure also in 13.4, where these are the magnetic field line, and they started from that of the north pole and enters into that of the south pole. So outside to that of the bar magnet, students, it seems that the magnetic field lines, it is emerging, or it is coming out through that of the line. It moves from the north pole to the south pole, but inside to that of the bar magnet, it will move from south pole to the north pole. Okay, so this is how we came to know that the magnetic field lines is starting from the north pole to the south pole, and it can be represented by the curved here. Now see here, magnetic field is what? It is the quantity that has both the direction and magnitude, and the direction of the magnetic field is taken to be the direction in which the north pole of the compass needle moves inside it. So magnetic field, it shows both the thing. It shows the direction also, as well as it shows the magnitude. Here the movement occur. So the magnetic field strength is there, and this strength is having a direction, and that direction is from the north pole to the south pole. Here one more thing is there of that of the properties of the magnetic line force, that these lines of force, they never intersect each other. And the magnetic line of force, if it is near the pole of the magnetic lines, if they are very close to the magnetic field lines, you will find that it is very near to each other at the poles, and which shows that the magnetic field at the pole is stronger as compared to other part. So you can see here that more number of a magnetic line of a forces, or the magnet even also. Suppose students, you will take a bar magnet, as we have seen in this case, where we have taken the bar magnet, and when we sprinkle the iron, you will find that most of the iron fillings will going to stick to the poles of the bar magnet, that is north pole and the south pole, and less amount of a iron fillings will going to stick at the, or will remain present at the middle. So which proves that the strength, the magnetic field strength, is more near the pole rather than to the middle. And when I said that the line of the forces, they never intersect each other, let us see here. See, the strength of the magnetic field is shown by the degree of the closeness of the field line, and the field is stronger, that is force acting on a pole of another magnet place is greater where the field lines are crowded. See, magnetic field lines, they never intersect each other. Okay, when they are closer to the poles, their field strength is really high, but they never intersect. What is the reason behind it? How can we understand it? So see, if two field lines, if they intersect each other, suppose, what does that mean? If they intersect, it means one of the field line is moving from the other direction, from the one direction, and other field line is moving to the opposite direction, right? And in that case, at that intersection, if you keep the magnetic needle, then the needle will point towards the two direction, because one is coming to the this side, and other one is coming to the this side. So if we will keep a magnetic needle here, the magnetic needle have to show two direction, and this is not possible at all. And it is because of that only we always say that the magnetic needle, they never intersect each other. Okay, so these are what, student, these are some of the properties of the magnetic line of forces or magnetic field. Now let us try to understand that how magnetic field is produced due to the current carrying conductor. So for this, so magnetic field due to the current carrying conductor. So we already knew that when the electric current, it passes through a conductor, through a metallic conductor, it will produces the magnetic field. And we can understand with the help of an activity. So as you can see here in the figure, here in the first one, in A, you will find that we have taken a long straight copper wire. A long straight copper wire is there, students, and to that of the copper wire, battery is connected, two or three cells of a 0.5 volt is attached with it, and a key is also inserted. Now parallel to this copper wire, over to it as well as parallel to it, we will keep a magnetic compass. Now what we will do, as you can see here it is actually explaining about the direction, because the kind of a deflection which will be shown by that of the magnetic compass, it will be easy for us to understand that where the deflection is produced or what kind of a deflection will be shown by the magnetic compass. Now let us see here, students. So when the electric current start flowing through that of this conductor, you will find that the magnetic compass will get deflected towards the east. Okay, it will move towards the east direction. Now what we will do, we will going to see that of the B also, and here also the same case. Here what we will do, we will going to replace the connection. When we replace the connection, the current will start moving in the opposite direction. And is there any change that you will find? Yes. Now the magnetic compass will going to deflect towards the west direction. So by this, first of all, we have understood here one thing, that a current carrying conductor will produces the magnetic effect. Magnetic field is produced, due to which there is a deflection shown by the magnetic compass. As well as we have understood here that when the direction of the current changes, due to which the magnetic direction, the magnetic poles also varies, or the direction also changes. Okay, so the we can say here that the movement of the electric current in a pattern will also going to decide the kind of a direction. So magnetic poles also get changed, or the magnetic effect also get reversed along with the if we reverse the movement of the electric current. We can understand this with the help of a straight current carrying conductor. So for this, there is a activity, student, again, in order to understand the kind of a magnetic field. Suppose we have taken because when we use the bar magnet, we have seen that some of the lines are curved lines, some of them emerges out from that of the bar magnet. So if we want to find out the kind of a the current, the kind of a pattern of a magnetic field lines produced in a straight current carrying conductor, we will do this activity. And here we will take a battery, a variable resistance or rheostat is there in order to change the resistance, students. In order to change the variable resistance is also in order to change the resistance. Okay, and an ammeter of 0 to 5 ampere, we will plug a key, a wire is there, and we will insert a thick wire through the center normal to the plane of a rectangular cardboard. This, take care that the cardboard is fixed and does not slide up and down. So we will take a cardboard, and this cardboard must have a hole in through which we will make the wire to enter through it. Now you can see here, it is like that. So this is a cardboard, and through cardboard there is a hole through which the XY. What is this XY? XY is the copper wire which passes through it, and this copper wire is connected to, it is connected to key, and the variable resistance is also there, the battery is there, and as you can see here, the cardboard is there. The cardboard is having a hole in it through which the copper wire can easily pass through it. Now when we give current to that of the the wire, the current, you can see here, this is the it's showing that the current is moving from that of the ammeter to resistance and entering into the wire, and again come back to the other terminal. So how we will come to know that the magnetic field is produced? And for that, the cardboard which we had taken, which is fixed, and in that of the cardboard, the thick wire which is moving around, the thick wire is present through which the current is moving around it. So when we sprinkle the iron filling uniformly on the cardboard, and when we gently tapped it, we will find that there is a formation of a certain shape, or a kind of a pattern, and that pattern is of a concentric circle around the copper wire. So this is the concentric circle. It's a kind of a circle around that of the copper wire. So what is a concentric circle here? Actually, this concentric circle, it explains about the magnetic field lines around that of the cardboard, and the direction of the magnetic field line is also explained here. Now if suppose we will keep we will when we keep a compass, a magnetic compass, near to that of the field line, we will be able to get that which is the which is the what is the direction of the movement of the field line with the help of the magnetic compass. Now, is it possible that if we change the magnetic field line, if we will change the setup, so what kind of the pattern that we will find here, student? If the direction of the current is changed, if the direction of the current is reversed, so what will be the direction of the magnetic field line? So we also find out that when we changes the direction of the current, then the magnetic field line also get reversed. Okay, and this we can understood with the help of the deflection of the needle. It means if we will keep the needle near to that of the cardboard where the pattern can be seen, you will find out that on reversing the current, then the compass needle also get reversed. So along with the concentric circle, the deflection of the needle can also be observed. So we can say here that by changing the direction, the magnetic field also it also changes the direction here. The magnetic field lines, now see students, when we keep the magnetic compass near to it, it will be very easy for us to understand that whether the magnetic field is produced here or not. Now, if the compass is moved away from the copper wire, but the current is flowing through the wire, it remains the same. So, what kind of a thing that you will observe? We will find out the deflection in the needle, it decreases, and by this we can say that magnetic field produced by a given current in a conductor decreases at a distance from it increases. So when the distance increases, then the magnetic field also decreases. If it is close, then the magnetic field can be it will be strong. And how we will come to know that it is away or it is close, students? So with the help of the concentric circle. Concentric circle is the circle which is formed around that of the current carrying conductor. If the concentric circle is large, we will say that the current carrying conductor is also the current carrying conductor is also producing a less amount of a magnetic field around it. Now we will going to study about the right hand thumb rule in the next class.